Okay, now that we have added fractions with like bases, added fractions without like bases, now we need to add and subtract mixed numbers. Adding and subtracting mixed numbers is not that challenging. In many cases, our first attempt is to do it the easy way. The easy way is to take the big numbers, put the big numbers together. 8 minus 2 is 6. Then take the fractions and try to put the fractions together. Now the problem here is I don't have like bases, so what am I going to need to do? Well, can I turn a 6 into a 3? No, I can't turn a big number into a small number, but can I turn a small number into a big number? Sure. What does it take to turn a 3 into a 6? Times 2. So I end up with 5/6 minus 2/6. Well, now I have the same basis. 5 minus 2 is 3 over 6. So I took the big numbers, put them together, the fractions, put them together, and it works out. 6 and 3, 6. Now, for some of you playing at home, you notice I can't leave 3 over 6 because I could reduce that. That's going to be 1/2. So we put those together just like that. Now, we could go over here and do the same thing. Let's do the easy method. Big numbers first, 5 minus 1. Little numbers, fractions, 4/5 minus 3/10. Well, 5 minus 1 is easy, that's 4. But what about 4/5 minus 3/10? I'm going to have to get common denominators. How do I turn a 5 into a 10? I need a 2. So I have 8/10 minus 3/10. The answer is 5/10. So my answer is 4 and 5/10 from bringing the whole number down to bringing the fraction down. Now again, you'll say 5/10 though. 5 out of 10 is 1/2. That's what needs to happen. Okay, that was the easy method. Method number 1, take the big numbers, do those first, then take the fractions, do those second. If you have to find a common denominator, that's fine. Let's do method 2. Method 2 is longer, has bigger numbers in it, but sometimes can be easier because in this case it's going to work every time. We're going to change them into improper fractions. Now to do that, to take any mixed number and change it to an improper fraction, you take the denominator times the whole number and you multiply. So 8 times 6 is 48. And then you add the numerator. So plus 5. So I come up with 53 over 6. Now let's do it again. Let's do it again. We're going to take 2 times 3, and that's going to be 6, plus 1 more, that's going to be 7. So I end up with minus 7/3. Now, you say, well, that's good because it's now just fractions, not mixed numbers. But I still can't add or subtract them because they're not like bases. I need to change a 3 into a 6, just like last time, by multiplying by 2 over 2. The answer is 53 minus 14 over 6 over 6. So the answer is going to be 53 minus 14. Well, if I have to, I can go to my calculator because I got big numbers. 53 minus 14, 39. 39 over 6. Now here's the problem with this method. Although it works, and it means I don't have to do mixed numbers, I can just do fractions, I now have to reduce. So if I try to reduce this, how many 6's go into 39? Well, 6 times 1, 6 times 2, eventually 6 times 6 is 36. So 6 whole numbers go into 39 with 3/6 left over. So that's 6 and 1/2. 6 and 1/2. So that's going to be the second method using improper fractions. Let's do it again, but let's do it with our other values. 5 and 4/5 minus 1 and 3/10. Okay, so 5 times 5 is 25, plus 4 more, equals 29 over 5. 1 times 10 is 10. Plus 3 more is 13 over 10. Now again, I can't subtract because I have 5s and 10s. So how do I change either a 10 into a 5 or a 5 into a 10? Well, I can't make a big number smaller. I got to make the small number bigger. So I'm going to go 2 and 2. Well, 29 times 2 is 58. All over 10 minus 13 over 10. And I come up with 45 over 10. Again, the challenge with this method is I can't leave 45 over 10. How many 10s go into 45? 4 go in, with 5 tenths left over, so I have 4 and 1. So it becomes 45 over 10, which means how many times does 10 go into 45? It goes in 4 times, because 4 times 10 is 40. And so I take 45, take away 40, leaves 5. I reduce 5 tenths to 1/2, and that's my answer. Okay, that's adding and subtracting mixed numbers.